Okay. So till now we saw the SGA, right? And we also saw how to configure this SGA. So this SGA, the important components of SGA or the mandatory components of SGA are database buffer cache, shade pool, Java pool, sorry. So we'll only go for the mandatory components, log buffer. I'll make this as log buffer. And the optional components we already know, shade pool, Java pool, large pool. I'll make it as SHP shade pool, Java pool and large pool. And you know how to configure them. You know each and every parameter how to configure them. And if you don't want to configure each and every component, we use automatic shared memory management. So if we want to use automatic shared memory management, we will only set two parameters. One is SG underscore target. Second one is SG underscore max underscore size. These are the two parameters which we need to set in order to use automatic shared memory management. And once you set these two parameters, you don't need to set each and every component. Like you don't need to set db underscore buffer underscore cache. You don't need to set log underscore buffer. At the same time, you don't need to set shade underscore pool underscore size, because this automatic shared memory management, it will automatically manage all of these components: buffer cache, shade pool, streams pool, Java pool, and large pool. It will not monitor or it will not manage the log buffer. Apart from this log buffer, rest of the components will be managed by automatic shared memory management. So once you set SG underscore target and SG underscore max underscore size, you don't need to worry about the individual component sizes like db buffer cache, db underscore buffer underscore cache. You don't need to worry about that. Share underscore pool underscore size, you don't need to worry about that. Streams pool size, all of those things, you don't need to worry about them. If you want to set a minimum size for database buffer cache, even though you're using automatic shared memory management, and if you want to set a minimum value for database buffer cache, in that case, you will set db underscore buffer underscore cache. So when you set db underscore buffer underscore cache, while the database is in automatic shared memory management, in that case, that value will be served as a minimal value. So every time automatic shared memory management, depending upon its usage, it will either allocate or deallocate from the component. But when it is trying to deallocate, it will check the value of buffer cache and make sure it will not go under that specified value. And coming to 11G, Oracle introduced another technology called as automatic memory management, AMM. So before going to automatic memory management, we need to know about another component which is present in the memory for Oracle database, that is PGA. Apart from SGA, we also have PGA in the database. This PGA is called as process global area or private global area. PGA is called as either process global area or private global area, and PGA is divided into persistent area, runtime area, and then you will have sort area, you'll have hash area, and you will also have bitmap merge. Bitmap merge. So these are the components of PGA. So every time, so let in a dedicated server mode, if you have the database on this server, listener will be running. you'll have the physical storage where you'll have the physical files, and then you will have memory structure. And remember, architecture is not divided into logical and physical. It is divided into two parts. One is instance and another is physical storage. So physical files plus an instance is nothing but a database architecture. And database architecture is nothing but study of each of the components of instance as well as physical files is nothing but architecture. And you'll have the server where you have the physical files, where you have the instance and the background process running on it. And whenever a user is trying to connect to the database, on behalf of the user, a server process will be created or forked by the listener process. Right? For each and every user process, we will have a server process. Now, this server process is the one which will have the PGA. So if you have 100 users connecting to the database, 100 users will have the PGA, and that PGA will be used. For example, if a user is issuing a command, select star from EMP, order by, ename. So in this case, it needs to retrieve the information from EMP table as well as it needs to sort the information based upon the employee name. So in order to do the sorting, it requires some memory. So usually it will use PGA in order to perform the sort. So that is the reason why one of the component of PGA is sort area. So PGA is basically divided into, as I said, persistent area and runtime. We'll see what is a persistent area and what is a runtime. But before going into that, basically PGA is used for sorting operations. And in PGA, one of the component is sort area, and this sort area will be used for sorting operations. So whenever you have any query with order by or group by clauses, in that case, it uses the sort area in the PGA. And for each and every user, there will be associated PGA process. So in dedicated server mode, if you have 100 users will have 100 server process which are running on their behalf on the server side. At the same time, each server process will have PGA, and that PGA only the server process. For example, this is server process and this is a PGA for the server process. Only this server process can access the PGA which is allocated for the server process. Rest of the server process cannot access the other server process PGA. That is the reason why it is called as private global area. Only one server process can access one PGA. Whereas if you take SGA, which is server global area, this server global area will be accessed by all background process. All background process will access the same memory segment which is called as server global area. It is also called as shared global area. The reason for that is all the background process will access the same memory. But in case of PGA, only the process which is specific to that PGA can only access the memory chunk. And that is the reason why it is called as private global area or process global area. It is specific to that process. And now whenever you have any order by or group by clauses, this sort area component in the PGA will be used in order to perform sorting or in order to perform groups. And not only that, whenever you are joining two tables, so there is another segment or another component in the PGA which is called as hash area. So we already saw the different joins which are available with SQL. Can you list some of the joins which are available in the SQL?
Inner join, inner join,
Mm-hmm.
left join, like outer join.
Okay. I'll first is equi-join. Whenever we have two columns, whenever we are joining any two tables based upon the columns, that is called as an equi-join. And we have a natural join whenever we join two tables with the same column name. In that case, it is called as a natural join. Apart from these two joins, we have outer join, which can be left or right. So these are the joins available with SQL Plus. But whenever you are joining those two tables, Oracle internally uses a different kind of join mechanisms in order to join the two tables. One of that join is called as hash join. This is nothing but an internal join. You don't need to worry about that. Oracle will take care of that. So whenever, for example, if I'm joining EMP and department table, EMP and department table, and if both the tables have same set of rows, for example, EMP table has 20,000 rows and even department table has 20,000 rows, in that case Oracle will use hash join in order to join these two tables. So it basically uses a hash mechanism in which it will join the two tables. So whenever it is joining the two tables based upon a hash join, it requires hash area. So it will use the PGA hash area in order to perform hash join of the two tables. Next, the third component of PGA is bitmap area. So we already saw how to create a bitmap index. Can I know why a bitmap index will be created? What is the difference between a B-tree index and a bitmap index?
Bitmap index match. I mean, we'll check the values from. I mean, yes or no.
Yeah, yes or no, that is correct. But whenever we have any column with low cardinality, that means whenever we have a column with less number of distinct values, in that
Okay.
case we'll create a bitmap index. And basically bitmap index is nothing but it will have a bitmap representation. That representation will determine whether the value which is being searched in the query is present in that specific row or not. So that information will be converted into a bitmap pattern. Whenever you create an index, in that index bitmap patterns will be stored, and that bitmap patterns will use the bitmap area of the PGA. So whenever you are creating an index, first it will convert the actual data into a bitmap pattern, and to store that bitmap patterns it uses the bitmap area of PGA. After that it will store that into the physical file, which is the index will be stored in a physical file, right? So once it calculates the bitmap patterns, after that it will push the bitmap patterns from the PGA to the index. Next, persistent area. So if you remember when I was telling you about the insert statement, and if you want that insert statement to be a generic one, insert into EMP, values ampersand 1 and ampersand 2. So whenever we are giving ampersand 1 and ampersand 2, it is called as a bind variable. So this variable will take the values during the runtime. It will prompt for the values to be inserted at the runtime. So whenever you are having these bind variables, the persistent area will be used in order to store those bind variables. Okay, and coming to runtime area, if you are doing a select star from EMP, it will keep track of how many rows are retrieved, still how many rows needs to be retrieved. So it will keep track of progress in the runtime area. This is about the PGA, and PGA plus SGA forms the memory part of the Oracle database. PGA is specific to a server process, whereas SGA can be shared by all the server process. I mean all the background process as well as all the server process. If you remember, server process is the process which will fetch the information from the physical files into the database buffer cache. That means if you have 100 users connecting to the database, we'll have 100 server process, and those 100 server process will fetch the information from the data files and it will store it into the buffer cache. So that means it is shared among all the process which are associated with the Oracle database, SGA. But PGA, it is specific to that server process, and that server process only can use that PGA. And basically it will use for sorting operations as well as to store the band variables, and also whenever you're creating any bitmap indexes, in that case also it will use bitmap area to store the bitmaps. Now till 10G, in order to decide how much of PGA can be allocated, we use two parameters, PGA underscore there are two parameters associated with the PGA. One is PGA underscore aggregate. Okay, there is only one parameter associated with the PGA, which is PGA underscore aggregate underscore target. So this will determine how much of PGA can be allocated to all the server process. For example, if I specify PGA underscore aggregate underscore target to be 200 MB, in that case, the total PGA allocated to all the server process cannot be greater than 200 MB. Okay, this parameter will be served as a value, or it will be served అర్థమైందండి. PG aggregate target, it is not specific to that server process, it is specific to all the server process. So PG aggregate target 200 MB పెడితే 100 సర్వర్ ప్రాసెస్ రన్ అవుతుంటే 100 సర్వర్ ప్రాసెస్ కి కలిపి టోటల్ PG ని డిసైడ్ చేస్తుంది పారామీటర్.
Yeah.
So till 10G we don't have anything like we have a separate mechanism to manage SGA and PGA. To manage SGA in 10G, to manage memory structures, we have two approaches. One is manual approach, where we need to set each and every component in SGA, plus we need to set PG underscore aggregate underscore target. So this is a manual approach which is available in 10G. The second approach is automatic shared memory management approach, where we need to set SGA underscore target, which will manage SGA components, and PG underscore aggregate underscore target to manage PGA. Next, coming to 11G, apart from about two methods, we also have another method called as AMM, which stands for Automatic Memory Management. Automatic shared memory management can only manage the SGA part, whereas automatic memory management can automatically manage SGA as well as PGA. So you don't need to set PGA aggregate target too. You'd only need to set two parameters. One is memory underscore target and the other one is memory underscore max underscore size. These are the two parameters you need to set in order to enable automatic memory management. So once you set these two parameters, you don't need to worry about rest of the parameters. You don't need to worry about SGA target, you don't need to worry about SGA max size, you don't need to worry about individual components of the SGA, as well as you don't need to worry about PGA aggregate target. You just need to set these two parameters. It will automatically take care of SGA as well as PGA. So if you set memory underscore target to 400 MB, that means for that specific instance, Oracle can allocate maximum of 400 MB, combining both SGA as well as PGA. And memory max size is similar to SGA max size, but this is the max size until which you can increase the memory allocated for the Oracle database. You can set it to equal. Usually it will be the same size, memory max, memory target and memory max size. But if you have more than 400 MB of memory available on the server side, if you want to decide like in the future maybe memory underscore target will be increased, in that case we will set memory underscore max underscore size to be 700 MB, such that in the future you can increase the memory underscore target to 700 MB. And remember, memory underscore target is the actual value which will determine the maximum size of memory which can be allocated for the Oracle database, combining both SGA as well as PGA. Now, when you are using automatic memory management, and this will automatically manage SGA as well as PGA, correct? But now, even this automatic memory management, if you want to set a minimum value for SGA as well as PGA, in that case, we can set SGA underscore target equal to 200 M, PGA underscore aggregate underscore target to 100 M. That means whenever it is managing SGA as well as PGA, it will make sure PGA will never go down below 100 MB and also SGA will never go down below 200 MB. Is it clear? Difference between automatic memory management and automatic shared memory management? This will manage both SGA as well as PGA. In 10G, we need to separately configure SGA and PGA.
Yeah.
Yeah. And this method, you can also use it in 11G. Manual approach or automatic shared memory management. But you have an additional feature with automatic memory management. So it's better to use automatic memory management itself.
Okay.
And whenever you are trying to modify memory underscore target, you need to make sure whether you have sufficient space under /dev/shm. So whenever you configure automatic memory management, it doesn't use the actual RAM. It uses a mount point called as /dev/shm. This mount point will be used for PGA as well as SGA. So for example, on /dev/shm, if you have 700 MB of space, then you can set memory underscore target to 700 MB, not more than that. So see here, df minus h will give me the total size allocated for each mount point as well as how much of space has been used on each mount point. Now /dev/shm mount point has 742 MB of space. That means I can set memory underscore target to a maximum value of 742 MB. I cannot go beyond this value. But if you are using automatic shared memory management, and if you are trying to set sg underscore target, it doesn't depends upon this /dev/shm. It depends upon how much RAM you have available on the server. For example, if you have 1.5 GB of RAM and if you are using automatic shared memory management, then you can set sg underscore target to 100, like 1 GB. But if you are using automatic memory management, you can only set to 740 MB. Of course, you can change the value how much needs to be allocated for this SHM. You can do that. You can deallocate the existing space and you can modify the size.
Okay.
For example, now I'll connect to the database. Show parameter SP file. Okay. I'm using SP file in order to start up the database. Now I will change memory underscore target. Alter system set memory underscore target equal to, okay, before doing that, let me check the existing values. Show parameter memory. Okay. Memory underscore target and memory underscore max underscore target. These are the two parameters associated with automatic memory management. I'm sorry. I made a mistake here. It's memory underscore max underscore target, not size. Okay. Now, memory max target is set to 632 MB and memory underscore target is set to 592 MB. Now I will change memory underscore max underscore target to 800 MB and I will see what will happen. Alter system set memory underscore max underscore target equal to 800 M. Okay. Can I know what is the mistake I made here? Depending upon this error, specified initialization parameter cannot be modified. So, do you guys have any idea why this errored out?
SP file we have to do, right?
Yeah.
Alter system set
Yeah.
memories.
Yeah,
And the
because
scope equal to-
this parameter is a static parameter, so you need to change the parameter with scope equal to SP file.
Yes. Yes.
Okay. So this will allow me to change memory max target to 800 MB on the SP file. Okay, it's done. Now if I do show parameter memory, still it will not be reflected for the current running instance. I need to shut it down and I need to bring it up, correct? So I will shut it down.
Yes.
Okay. Okay, now I'll try to bring it up. I'll see what happens. Okay. So if you see here, memory underscore target not supported on the system. Can you know why? Any idea why this errored out?
We give like 800 M, right? It's maximum size
Yes. So what I have to do now?
We need to create the P file from SP file, and we need to change the value to
Yes,
less
correct.
than 632
Yes, correct.
in P file, and another we have to create SP file for
Yep.
the P file.
Yep. So now if you see, the database is not up and running. Even when the database is not up and running, we can create a P file from the SP file. So I can just connect to the database, connect / SSDBA, and I'll issue create P file from SP file. Okay. Now I'll have text file in Oracle Home / DBS location. By default,
Yes.
it will create the P file in Oracle Home DBS.
Yeah.
Here, I'll modify memory max target to
600 something. Yeah.
yeah 680 M. No, 690 MB. I'll connect to the instance, idle instance again, and I'll issue create SP file from P file.
Yeah.
So this will override the existing SP file. Now I'll issue the startup command. So this is how you need to change whenever you're using an SP file, and if you want to change the value when the database is down, you need to create a P file, you need to modify the entry, you need to create an SP file from that P file, and you need to start it up.
Okay.
Okay, now show parameter memory. Okay, so memory target is set to 592 MB. That means 592 MB of memory can be shared between SGA and PGA. Now let me check, did I configure SGA target? Okay, if you see here, SGA underscore target is not set. It is set to 0. That means there is no minimum value set for SGA. Depending upon its usage, it may shrink down to 10 MB or 20 MB. Depending
Okay.
upon PGA usage, it may go up till 500 MB. Depending upon their usage, it will either deallocate or allocate from both the components. In a similar way, let me check the PGA. Did I set any value? No. Now, that means I left everything to the Oracle such that it can manage SJ and PGA. There is no minimum guarantee that SJ will be of this much size and PGA will be of this much size. In order to guarantee that, you need to set SJ target as well as PGA aggregate target. Now, out of this 500 MB, all the time I want to guarantee at least 300 MB needs to be allocated for the SGA. In that case, I will set SGA target, alter system set SGA underscore target equal to 300 M. So this will all the time it will guarantee that at least 300 MB is allocated for the SGA. Next, for PGA, I want to guarantee 100 MB. So all the time SGA size will be at least 300 MB and PGA size will be at least 100 MB. And within this 300 MB, if you want to guarantee database buffer cache to be 100 MB all the time, you need to set DB cache size. If you don't want to set a minimum size, you can just leave it out like that. So DB cache size is set to 0. So that means you cannot guarantee the size of database buffer cache. Clear, huh?
Clear, yeah.
Yeah. And next, we will see another parameter. I mean, like, okay, Oracle will automatically manage SGA as well as PGA by setting memory underscore target. That is fine. But how much of memory should I be allocated for memory underscore target? So ఎంత memory నేను memory underscore target calculate చేయాలో కూడా నాకు తెలియదు. So in that case, what I have to do? So RKill will give us advisories. So looking at that advisory, you can determine how much of size I need to be allocated for memory underscore target. In initial case, you can allocate some minimal value. For example, if you have 2 GB of RAM on the server and you have only one database, in that case, you can allocate until 70% of the total available RAM, such that rest of the 30% will be used by rest of the Oracle processes as well as rest of the Unix operating system process. But is that value efficient or not? So either you can set maximum 70% allocate చేసుకోవచ్చు, లేదు అంటే తక్కువ కూడా allocate చేసుకోవచ్చు అవైలబుల్ సర్వర్ ర్యామ్ కన్నా. సో
Okay.
ఆ అవైలబుల్ ర్యామ్ చేసిన తర్వాత ఆ వాల్యూ కరెక్టా కాదా, వెదర్ ఇట్స్ అక్యురేట్ వాల్యూ ఆర్ నాట్, అది చూసుకోవడానికి అడ్వైజరీ టూల్స్ ఉంటాయి.
Okay.
సో వన్ ఆఫ్ దట్ విల్ బి $v memory underscore target underscore advice. This view will show us whether the value which we set is properly configured or not. Select start from $v memory underscore target underscore advice. Okay, so if you see here, memory size factor is 1. So the column value corresponding to the memory size factor, if it is 1, that means that is the current size of the memory max target, which is 592 MB. So the current memory max target size is 592 MB, and by setting that, estimated DB time, you need to look at the estimated DB time. So now the estimated DB time is 44. ఇక్కడ యాక్చువల్గా మీరు యూ కెనాట్ సీ లాట్ ఆఫ్ డిఫరెన్స్, బట్ ఇన్ ద రియల్ టైమ్ యూ కెన్ సీ లాట్ ఆఫ్ డిఫరెన్స్. సో ఇన్ కేస్ ఇఫ్ యూ ఇక్కడ ప్రెడిక్టబుల్ ఉంటుందన్నమాట. 592 MB కంటే చిన్నగా చేశారనుకోండి, ఇఫ్ యూ గో బిలో 592 MB, ఇఫ్ ద ఎస్టిమేటెడ్ డేటా టైమ్ ఇంక్రీజెస్, ఇన్ దట్ కేస్ యూ షుడ్ నాట్ గో బిలో దట్ బికాస్ ఇట్ విల్ ఇంపాక్ట్ ద పర్ఫార్మెన్స్.
Okay.
And if you go above 592 MB and your estimated database time decreases, that is well enough, you can increase the size. But till how much size you can increase, you need to make sure ఇప్పుడు 500 MB కన్నా కాకుండా 740 MB ఉంది అనుకోండి, ఎస్టిమేటెడ్ DB టైం కనుక 22కి వెళ్ళింది అనుకోండి, ఇన్ దట్ కేస్ యూ కెన్ ఇంక్రీజ్ మెమరీ టు 740 MB. అది చేసే ముందు యూ నీడ్ టు చెక్ ద నెక్స్ట్ హైయర్ వాల్యూ. 888 MB ఉన్నప్పుడు ఎస్టిమేటెడ్ DB టైం కనుక 31 30 ఉంది అనుకోండి, దెర్ ఇస్ నాట్ లాట్ ఆఫ్ డిఫరెన్స్ బై ఇంక్రీజింగ్ ద మెమరీ. In that case, you can safely set it to 740 MB. So using the memory target advice, you can determine. In a similar way, you'll also have $v sg underscore target underscore advice. Yeah, so depending upon the physical read count, you can determine what should be the SGA size. So actually మీరు memory target advice చూసే కన్నా కూడా it's better to use SGA target advice. So depending upon the physical reads, you can determine what should be the SGA size. If by decreasing SGA size, if it increases the physical reads, then it is not safer to decrease the SGA size. Okay Nandi?
Yeah.
Okay, so this completes the total memory structure. Next we will see only one of the background process is missing, CKBD checkpoint. We will see what is a checkpoint and how it how it updates the data files and all those things. After that we will see how SMON will perform an instance recovery. So once you understand the checkpoint concept, you can understand how SMON background process will perform an instance recovery.
Okay.
Basically, in Oracle database, you have SCN, which stands for system change number. You have another term called as checkpoint change number. System change number is a number which starts with 1 and increases and increments for every 3 seconds. Database create చేసినప్పుడు SN number 1 తో స్టార్ట్ అవుతుంది and it keeps on increasing for every 3 seconds. It will increment by 1. For
Okay.
every 3 seconds it will increment by 1. Next, checkpoint change number is the SCN at which checkpoint is issued. So when a checkpoint will be issued, whenever log writer performs a log switch, in
Yeah.
that case a checkpoint will be issued. So ఆ చెక్ పాయింట్ ఇష్యూ అయినప్పుడు ఆ స్పెసిఫిక్ ఎస్ఏ నెంబర్ ఎంతైతే ఉందో అది చెక్ పాయింట్ చేంజ్ నెంబర్ అవుతుంది.
Okay.
SCN number at that time when the checkpoint is issued, that will become a checkpoint change number.
Okay.
So what a CKPT background process will perform? Checkpoint process will update data files with a checkpoint change number, which will guarantee that until that specific SCN, until that specific number, the data is returned to the physical files. So for example, 7:30 ki log switch happened at 7:30. That means checkpoint change number will be the SCN number at 7:30 p.m. and this checkpoint change number will be updated on data file headers, and data files are the physical files which will have the actual data. So this will update the data file headers. But when it will update the data file headers? So when a log switch happens, it will trigger the CKPT process, checkpoint process. But CKPT in turn will trigger DBWR process. Correct? So
Yeah.
this DBWR will write the dirty buffers from buffer cache to the data files. So once DBWR writes the dirty buffers from buffer cache to the data files, after that it will update the data file with that checkpoint change number. ఎందుకు so that అంటే ఆ checkpoint change number వరకు until that time all the data which is present in the memory has been written back to the data files. So in the physical storage
Okay.
we have the data till that point of time. So CKPT first it will trigger DBWR. Once database writer writes the data buffers from the buffer cache to the data files, then it will update the data file headers with the checkpoint change number. Not only that, CKPT will also updates the checkpoint change number in control file. Did I explain what a control file will have?
Yeah. It will have the all data related to debug files and data files.
It's not data. Control file is a physical file of the database. It's another physical component of the database which will have the locations
Yeah,
of
okay. Yeah.
data files and control files. Apart from this, it will also have current SCN as well as latest checkpoint change number. So apart from the location of data files and control files, it will also have current SCN and latest checkpoint change number. Now, CKPT, so CKPT ఏం చేసిందంటే two tasks. First, it will trigger DBWR. After that, it will update the data files and control file with that checkpoint change number. Okay, now, and do you get the difference between an SCN and a checkpoint?
Yes.
Okay. So if you want to see the SCN, you can do select current underscore SCN from $v database. For every 3 seconds, it will increment by 1. Okay. Current underscore SCN will give the current SCN, and for every 3 seconds it will increment by 1. And after that, if you want to see the current checkpoint change, if you want to see the latest checkpoint change number, so select current underscore SCN checkpoint underscore change number from $v database. This will give you the current SCN as well as checkpoint change number. And whenever you are querying this information, it will actually get the numbers from control file. Control file will have the SCN, current SCN as well as the checkpoint change number. So this is the current SCN and this is a checkpoint change number. That means until this change number, all the content is already present in the physical files. The difference between these two numbers will give you how much of data is present on the SCA, which is not yet written back to the data files. For example, if you want to convert an SCN into a timestamp, ఈ SCN నెంబర్ ఉంది, బట్ ఈ SCN నెంబర్ని ఒక టైం స్టాంప్ కి కన్వర్ట్ చేస్తే you'll get a better idea until what point of time we have the data in the data files. So in order to get that, we use a function called as SCN. One second, I forgot something. This is a function which will convert a system change number into a time period. So if I give 1026372 from $v database, no, from dual. So if you see here, the timestamp corresponding to this SCN number is 30th April 9:03 p.m. 9:39 p.m. Now, the same thing if I go for 1025375. The timestamp is 8:45 p.m. That means until 8:45 p.m. whatever the transactions which we made are present in the data files. The transactions which are made after 8:45 p.m. are still present in the memory. It is not yet written to the data files. By using these two numbers, we can determine until what period of time we have the content in the data files and what of rest of the data which is present in the memory. Okay? Is it clear?
Yeah, it's clear.
if I increment the 375 to 376, we'll see what will be the time. It should be three more seconds. 8:45 3 p.m. Okay, there is some problem. See, after 3 seconds, it got changed to 40. Now this 40 will be the, okay, 44, 44, 44. Then it will go to 47. So SA number will increment for every 3 seconds. Just to show you, for every 3 seconds it will increment. For 3 times you'll get the same timestamp. After that it will increment. Okay?
Yeah. Yeah.
Now, so now if I have to shut down the database, or for example, power failure occurred and the database went down. That means whatever the transactions which are made between 8:45 p.m. to 9:07 p.m. those needs to be restored, correct? Because 1025.375 gave us 8:45 p.m. So whatever the transactions which are made
Yeah.
after 8:45 to 9:03 p.m. needs to be recovered, and that recovery will be taken care by SMON background process. So that means in order to open the database in a consistent mode. So opening a database in a consistent mode is nothing but an instance recovery. And in order to open the database in a consistent mode, first it will check the current SCN of the control file. So when the database will shut down, for example, power failure అయిపోయింది అనుకోండి, ఆ టైంలో ఏదైతే SN నెంబర్ ఉందో అది కంట్రోల్ ఫైల్లో ఉంటుంది. And at the same time, it will also have the latest checkpoint change number. So by looking at the
Okay.
both the timestamps, it will determine what are the transactions needs to be recovered, and it will get that information from the redo log files, and it will perform the instance recovery.
Okay. Yeah.
These are SMON will perform the instance recovery.
Mhm.
ఏమైనా డౌట్స్ ఉన్నాయండి ఇక్కడ దాకా?
Yeah, లేదండి, క్లియర్ అండి, బాగానే ఉంది.
Okay. Next, we already saw control file will have the location of the data files, redo log files, and also it will have the SN number and checkpoint change number. Now, the control file is also a binary file. Like the SP file, control file is also a binary file. So we cannot view the content of this control file. I mean, like it will be in some other format, so you cannot read it. It will not be a readable format. So in order to get the information which is present in the control file, we can issue a command called as alter database backup control file to trace. So this will generate a text format of the control file. So as control file is a binary file, in order to view the content of the control binary file, we'll use alter database backup control file to trace. This will generate a readable format of the control file. But where this file will be present? So another set of physical files associated with the database are called as trace files and alert log. These are the another set of physical files which are associated with the database. So basically physical files if you go to the physical file part or physical components of the database, first one we saw is parameter file. Second is control file. Third, redo log files. Fourth, data files. And fifth, arclog files. Apart from these physical components, we also have alert log file and trace files. So basically, alert log file will give you the information about the changes which are performed on the database. For example, if you do any insert or if you do any update, it will not be registered into the alert log. But for example, if you change memory target or if you change SGA target, in that case, it will add an entry into the alert log saying that at this time period or at this time, the parameter has been changed from this value to this value. So whenever you do any structural changes at the database level, all those will be recorded into the alert log.
Okay.
This will be taken care by SMON. SMON process will add those entries into the alert log. Next, trace files. So there are different types of trace files. One set of trace files are called as background trace files. The second one is user generated trace files. And third one is audit files. We saw several background processes which are associated with an Oracle database. So all those background process will write something into a file. Those files are called as background trace files. So whatever the operations they are performing, for example, if SMON is performing instance recovery, it will add that, like whatever it is performing, whatever the instance recovery it is performing, it will record that into a trace file. So that trace file is called as SMON trace file. In a similar way, PMON will also have one trace file. Sorry, actually SMON will not have any trace files. So this may be an interview question. Every background process will have an associated trace file except SMON. So whatever SMON will be performing, it will be on the alert log. And PMON, ARCH or log writer or else CKPT, all those background process will have associated trace files. So the trace files which are generated by background process are called as background trace files. Apart from SMON, rest of the background process will generate the trace files. And these background trace files will be stored in a location, and it is determined using this parameter background underscore dump underscore dest. So in a parameter file, you have this parameter which will determine the location of background trace files. And user generated trace files are the trace files which are generated by the user. For example, if you see this one, this command will generate a trace file. That means a user generates this trace file. So it will be stored in user trace file location. Trace files which are generated by user are called as user trace files, and the location of the user generated trace files can be determined using this parameter user underscore dump underscore dest. This will give you the location of user generated trace files. And audit trace files, this you'll know in the feature class, but this will be determined using this parameter audit underscore file underscore dest. So whenever you perform any DDL operations or whenever you log into the database, it will actually audit your sessions. So when did you logged in, when did you logged off, what are the actions you performed, all those will be written to the audit files. So if user comes in and if he asks like when did I logged in, so you can look at those audit files in order to check when he logged in. But in order to generate these files, there is another mechanism you need to enable at the database level. So you'll see that in the future classes.
Okay.
These files will have audit related information. Now, if I issue this command, alter database backup control file to trace, let me issue this command. So this will generate a trace file at user underscore dump underscore dash location. So I need to check in show parameter user underscore dump underscore dash. Okay, this is the location where I have this trace file. So let me go to that location. So usually the trace files will be present under Oracle base, which is Oracle APP Oracle, followed by diagnostics. DIAG stands for diagnostic information, followed by RDBMS. Because this is an RDBMS software, this diagnostic information is related to RDBMS. So under RDBMS, you will have database name, which is test, followed by instance name. Instance name is also test here, followed by trace folder. In this location, you have the trace file which you generated. So usually the user generated trace files will have instance name underscore ora underscore some number dot trc. User generated trace files will be of this format, sid underscore ora. If it's a background process trace file, it will be of sid underscore background process name. So by looking at the file name itself, you can distinguish a user generated trace file and a background trace file. Now, so first in the beginning you will have some information like who generated this one, everything. So if you see here, so from SQL Plus utility, this trace file has been generated, and this trace file was generated by user sys. And after that, you will have the content of the control file. So if you see here, it has the arclog definition, and after that, you will have the log file, redo log file destinations, redo log file locations. So these are the locations of the redo log files. And after that, you'll have the locations of the data files. And if you want to check the current SCN and checkpoint change number, you look at VDOL database. That will not be written into the trace file. Okay. Now, if you don't have any control file, for example, if you lose the control file, we cannot bring up the database, because control file is very important as it has the location of data files as well as redo log files. So if you lose a control file, we cannot bring up the database. Using parameter file, only instance can be started. If you don't have the control file, you cannot get the location of the data files, right?
Yeah.
So control file is like a heart for the database. It's very important, and we need to make sure we'll never lose the control file. And in order to make sure we'll never lose the control file, we'll actually use multiplex mechanism for storing the control files. So multiplexing is nothing but storing the same control file in different locations.
Okay.
So show parameter control underscore files will give me the control file location. So show parameter. Okay, so these are the location of the control file. So one of the control file is located in /database test control01.ctl, and the another control file is located in different location. So if I lose any of this control file, I will still have another control file in order to bring up the database. In a similar way, you can give a different location. Right now I have only 2 control files. Like that, you can have n number of control files.
The two control files they having same, same values, right? Mohan?
No. This is control01.ctl. The control file names will be different, but it will have the same content.
Same data. Okay.
Yeah. Whatever the information is written to the control01, the same information will be written to the control02.
Okay. Yeah.
Such that if you lose control01, you can bring up the database using control02
Okay.
or vice versa. Now, let me show you how to perform multiplexing. Right now, I have the control file in two locations. Let me multiplex the control file into a different location. Like, I want to multiplex the control file in such a way that I need to have two copies apart from the current control file. So, right now I have only one copy. control01.ctl, control02.ctl. అంటే existing control file కి ఒక copy ఉంది. I want to have one more copy. So in order to do that, first we need to set control underscore files parameter. Alter system set control underscore files equal to slash database slash test. Here I'll give the third control file location. I want to put it in /home/oracle slash control03.ctl. Okay. Now I'll not change the value at the memory level. It's a static parameter. We need to change it at the SP file. So I'll give scope equal to SP file. Once we change the parameter, we need to shut it down. So whenever we are multiplexing a control file, we need to make sure we need to bring down the database. After that, we need to copy the control02 or control01 as control03.ctl. The reason for that is whenever the database is up and running, for each and every 3 seconds, control file will be updated. So it is not advised to copy the control file into a different location if the database is up and running. So you need to bring down the database. After bringing down, you need to create another copy of the control file. Now the database is down. Exit from SQL. Database test control01 dot. Okay. In this location, I have control01.ctl. Now I want to copy control01.ctl as control03.ctl, and that needs to be stored in /home/oracle. So what command should I use? I need to copy this file into a different location.
CP.
Yeah. CP control01.ctl space /home/oracle. So this will copy control01.ctl to home oracle. But while I'm copying, I want to rename it. So I'll also name the file control03.ctl. So this will copy control01 as control03. Once I copy the file, I'll connect to SQL Plus and I'll start up the database. Okay. Now I'll go to one of the control file location, for example control01.ctl, and I'll remove this file. think that this got corrupted. In the real time, you will not remove it if it is corrupted. I cannot show you how to corrupt the file, so I'll remove the file. Okay. Now, still the database will be functioning properly. In the real time, you may get some errors, so I'll shut it down first. Okay. So if you see here, it says cannot open the specified control file, unable to open the file. So it is unable to shut down the database. So in this case, you need to shut the database using shut-abort. Tomorrow I'll tell you what are what are different ways you can shut down the database. For now, we'll just use shut-abort.
Okay.
We'll exit from CTL plus. We don't have control01.ctl. So now, using the another control files, either using the control file which is present in flash recovery area, or by using the control file which is present in home Oracle, we need to copy the file into that specific location. So I'll go to home Oracle. I'll copy control03.ctl. Okay. cp control03.ctl space database test control01.ctl. Once I copy the control file, I can start up the database. Okay.
Yeah.
I'll wind up the class and I'll continue tomorrow.
Okay.
Okay then. Bye.
Bye. Thank you.
Bye Ashish.